guys, this is just a quick video to show you how to solve for molarity and just kind of like what molarity is, what it means. So molarity is the unit that we use to measure concentration in chemistry. So I'm just going to write that in there. It measures concentration. So remember, concentration is the ratio of solute to solvent in a solution. And the units of molarity are moles per liter. So like moles over liters. So whenever we are solving for molarity, you're going to end up needing to divide moles by liters. There is an abbreviation for molarity. A lot of people will abbreviate it as capital M. So people will write molarity as moles per liter or capital M. They both mean the same thing. So we're going to do just two examples of how to solve for molarity. So this question says, what is the concentration in moles per liter, which means molarity, where 0.506 moles of aluminum sulfide has been dissolved in enough water to make 1.2 liters of solution. So you can probably see this problem is pretty easy because it gave me moles and it gave me liters. I know that molarity is moles over liters, so all I have to do is do 0.506 moles divided by 1.2 liters. And I'm just going to plug that into my calculator. And my answer is 0.42. And I can either write that as moles per liter or capital M. All right, that's an easy problem. Now let's look at this one. What is the concentration in moles per liter? Same question as before. Where 42 grams of copper iodide has been dissolved in enough water to make 600 milliliters of solution. And then I'm giving you a hint here. Remember, the final units must be moles over liters. So in this problem, they've given me the stuff to find molarity, but instead of moles, they gave me grams, and they gave me 600 milliliters. So we're going to need to convert some stuff. The easiest way, I think, to set up these problems is to set up a conversion factor table, kind of like this. And you know how sometimes we would have problems a long time ago where we were converting, like, say, miles per hour to kilometers per second or something like that, where we were converting both the top and the bottom? We can do something like that for molarity. So we're going to need to have moles on the top for molarity, right? And our thing that's going to turn into moles is grams. So we could start with 42 grams of copper iodide on the top, and then our number that's going to turn into liters is the 600 milliliters. So we can just put that on the bottom. And hopefully that makes sense. This is going to turn into moles, this is going to turn into liters. So this needs to be on the top, this needs to be on the bottom. And then we're just going to need to plug in some conversion factors here to convert these. So hopefully you remember that to convert grams to moles, we have to use molar mass. So I'm going to find the molar mass of copper iodide down here. Let me just grab a periodic table. Okay, so the molar mass of copper is 63.55. And then I've got two iodines, so that's going to be 126.90. So just going to add those up. So 63.55 plus 2 times 126.9, and I got 317.35. And that's going to be grams of CuI2 per 1 mole of CuI2. All right, now I want grams to cross out, so I'm going to put 317.35 on the bottom and 1 mole on the top. So my grams can cross out like that. So now, if I were to solve this, I would end up with moles over milliliters, which is almost molarity, but not quite. This milliliters needs to turn into liters. So I can cross out milliliters way over here, so I can say there are 1,000 milliliters in 1 liter. My milliliters will cross out. And then I'm going to end up with units of moles on top and liters on the bottom. So what I'm going to do is I'm going to multiply everything on the top, which is going to give me 42,000. And that would be units of moles. And then I'm going to multiply on the bottom 600 times 317.35. And I got 190,410. And when I divide those, I get 0.22 moles per liter, or you could write capital M if you want to. And that's how you find molarity when they give you something other than moles and liters. Now, if they had just given me liters here, I wouldn't have to do this step. I could stop right here, because then I'd have moles over liters. But since they gave me milliliters, I had to do both of these conversions. All right, so let me know if you have any questions. That's how you solve for molarity.